Wire gauge is one of those things that people might hear about all the time but don't always understand. Thicker wire, thinner wire, copper, aluminum. There's a lot of varieties, so what's the best for you to choose in certain situations? So welcome back to the lab where our opinions cannot be bought. As you guys know, we don't only exist to give you honest feedback on products and save you money where we can, we also exist to hopefully give you guys information so you don't need an electrical degree when working with these solar systems. You can support the channel for free by subscribing down below or checking out some of our other videos. So why do different wire sizes exist? Wire gauge is about one thing: how much current a wire can safely carry. Current measured in amps is what creates heat in a wire. The more amps you push through a wire, the more resistance happens, and then that resistance creates heat. And low current loads don't generate that much heat, and so they can use thinner wire. And high current loads obviously generate more heat. Think about something like a hot tub, an oven. Those are gonna have way thicker wires because they're carrying a much larger current through them. And that's why smaller appliances like a lamp use such tiny little wires. If you're running a low amp circuit like a few lights, a small wire is fine. But as soon as you start powering things like a heater, your oven, the current's gonna be much higher. So in order for there to be less resistance, the wire size has to increase alongside it. And if you install the wrong breaker size for your wire, let's say you put in a 20 amp breaker, but you have a 14 gauge wire, it can overheat way before it trips. When dealing with different types of electrical current, if you're using DC or AC, you might think that if they're running a certain amperage, you'd be using the same size wire. And that's not necessarily true. With the same current, your wire gauge might actually need to be different. And DC systems usually operate at lower voltages, which means they need higher current to deliver the same amount of power. And with the higher current, you're gonna need to size your wires appropriately to keep those wires cool. And then AC systems typically run at higher voltages, at least 120 volts. In some situations, you might be using 240 volts. And this means that they could deliver the same amount of power with lower current. So they can get away with using smaller wires. And the breakers don't protect your appliances, they protect the wires. If sized correctly, your breaker is going to protect your wire before your wire overheats. And that is why your breaker size and wire gauge has to match. And so as you guys probably know, copper is used most often for wiring. It's kind of the gold standard. It conducts electricity really well, handles heat, and it's mechanically very strong. Aluminum, on the other hand, has higher resistance. It expands and contracts more often, and it's prone to connection issues when it's not installed properly. Another thing that you have to do, which you don't really have to do with copper, is apply this oxidization paste. It's gonna oxidize faster than copper does, and that oxidization paste is going to protect it. This is something that some people might actually miss when installing it. And this is actually why aluminum wiring inside of homes gained a bad reputation. Poor connections led to overheating issues. Also, its strength. If an electrician was pulling wire through a house and they pulled too hard, it actually would make a bit of a weak point in the wire, creating a smaller gauge, and that smaller gauge would be a hot point. The hot point could essentially become a fire hazard later on. But with that said, a lot of people, when they hear aluminum because of this, think that you never want to use it, or that no one even installs it in modern usages. But this isn't true at all. A lot of homes are going to be running aluminum wiring from the transformer to their panel. When sized correctly and installed properly, aluminum works really well. And it's cheaper. When you're laying down aluminum wiring into a trench, you aren't going to be pulling it through tight spaces. And so you don't really have to worry about that wire stretching like I mentioned earlier. But on the other hand, for inside applications, you're mostly going to be going with copper wire. It costs more, but it's a safer option. And you've probably heard solid wire versus stranded wire. Solid wire is exactly what it sounds like. One solid conductor. It's stiff, it holds its shape well, and it's usually used in residential branch circuits. And stranded wire is made of many small strands twisted together. It's more flexible, vibration resistant, and it's easier to route in smaller spaces. And as wire size increases, solid wire actually becomes impractical. I mean, imagine you get up to like 4 gauge wire. The cost on that is going to be crazy, and it would be too stiff to work with. So typically when you get to about 8 gauge, it switches over from solid wiring to stranded. It's made up of a bunch of smaller wires twisted together. So the solid is great for walls, unless you get up to the higher gauges, you get into stranded. But if you need really flexible wire, stranded is the way to go. And that's why you commonly see it in lamps and appliances. If you were to ever cut into one of those wires, a lot of the time you will see stranded wires. And on top of that, a lot of the time those shorter wires are also aluminum. And just a fun fact about Romex ground wires, let's say you have a 14-2 wire. Basically, that means gauge 14/2 2. The 2 just means 2 conductors or 2 travelers, but you're gonna have a third. It doesn't count the ground. When we get up to 14.3, it's gonna have 3 carriers in one ground. So 4 in total. That ground wire is actually going to be 1 gauge smaller than what the 2 current carrying conductors are. So if you have 14.2 wire, you're actually going to have a total of 3. You're going to have the black, which is your hot. You're going to have the white, which is your neutral. Both of those will be 14 gauge, but your ground wire with no insulation on it is actually going to be 16 gauge. So if for some reason you ever needed a certain gauge wire and you saw that you only had ground wire laying around, don't just assume that because it came from a 14.2 wire that it's actually going to be 14 gauge. It's going to be 16 gauge. Or if you're working with 12 gauge, it's going to be 14 gauge. And the reason for that is because the ground is not meant to carry continuous load. It's only there for a dead short. So if it does carry a load, it's going to be for a super short amount of time. And it's designed to trip the breaker with the magnetic tripping mechanism. And we get into that with our breakers in another video. And here's one of the most important concepts in electrical systems. As a lot of you guys probably know, if you increase the voltage, you can decrease the current and then deliver the same amount of power. And this can help you get away with a lot here. Some people will specifically design their solar array to be set up in a situation where it increases the maximum amount of voltage that they can increase it by, so that they can get away with using much smaller gauge wire to transport the same amount of power. If they did it the other way around and they were increasing the amperage and keeping the voltage low, they would have to increase their wire size to match whatever was needed to keep those wires cool. And this is actually why power lines operate at extremely high voltages. And this is also why solar systems are moving towards higher voltages for their solar arrays, battery banks, and inverters. So if you're trying to get the best bang for your buck and keep your costs low, it might be worth it to try and increase your voltage and also keep your wires as short as possible. Because if you have to run your power very long distances, you get into what's called voltage drop. And to compensate for the voltage drop, you have to increase the gauge of your wire size so that voltage doesn't continuously decrease. It basically keeps your voltage higher because there's less resistance. So it's worth it to put some time into properly designing your system to save the most amount of money you can on your wires. Just because traditionally DC systems are using lower voltages and higher currents doesn't mean you have to stay fixed within that world. You can alter it to save money. So that's it. I hope that this video helped you guys understand wire sizes and the different wire types and gave you guys a little bit more information so that next time when you go to set up your solar system, you can optimize it for the best bang for your buck. Hopefully this made you guys understand wire gauges and why they actually matter. And if it helped, hit the like button and subscribe down below, and we'll catch you guys in the next one. Thanks so much for watching. Peace out and stay charged.